Okay, in this video I'm going to introduce you another way of approximate roots. Okay, or know where the root is located, or it's by searching for the sign change. The keyword is searching for the sign change. In the previous lesson that I teach you is that we go into using the graphical methods, right? The graphical methods. Where you use the graphical methods, we know that okay, it's between 1 and 2. There is a roots, right? There is a roots because there is an intersection point. Or we say you see that between 0.5 and 1 there is a roots, right? So it's using graphical method, alright? This is what we call as a graphical method, alright? All of this is called graphical methods. So we want to see, oh, there is a roots in between 0.0 and 0.5, right? We know there is a roots, and we can see approximate the root from the graph. Okay, there is another way we call searching for a sign change, alright? Searching for a sign change. So okay, I'm not going to read the text here, so I'm going to tell you. Let's say if I'm asking what is the roots for x minus 4, right? What is the roots for x minus 4 equals to 0? Do you know what's the roots or not? Means that the roots here means that, okay, let's say you have a graph of y equals to x minus 4 and it asks you to solve the equation of x minus 4 equals to 0, means to find the roots, punca yang menjadikan dia kosong. What is the value of x that it becomes 0? Definitely x will be 4, right? 4 minus 4 is 0. So that's why the x will become the roots for this equation. So okay, so I'm going to show you. So I'm using this simple concept here, okay, to later to extend the knowledge. So I have to tell you, for example, this one x 0. So x minus 1 means at 4, and okay, of course there is a negative 4 here, but this is not important because now I want to know the roots, right? I want to know the roots. So let's say this is my function, okay, this is my function. To solving, I know that fx will be 0, right? It's actually a y. So I want to find the value of x such that it's 0. The x value that will 0 will be 4. 4 will be the roots, right? So then I can say that fx will be equals to x minus 4, or it's actually the y value here, right? So now I'm asking, what is the value of 5 here, right? What is the value of 5? Of course, the value of 5, when they mix the graph, they were giving you a positive value, right? Positive value. Okay, if you don't, you say 5 minus 4. 5 minus 4, when x is 5. So what is the value of y? It will be 1, right? 1, positive 1. So let's say I choose, okay, this is the roots. This is the roots. So this root is between 5 and 3, for example, 5 and 3, right? 3. So while x is 3, so the y value will be negative. So negative means that when x is 3, so 3 minus 4, you are getting negative 1, right? Negative 1, positive 1. Can you see the sign change? This is called as sign change, perubahan sign. Okay, perubahan tanda positive jadi negative, negative positive. This is only happen when there is a root between these two, right? The root is 4, right? So if I want to know, is there a root for fx in this interval, I must see 5, okay, 1 will be positive and 1 will be negative. Then I can surely say that there is a root between 3 and 5. But this is only valid if the graph is continuous, alright? Is continuous in this interval, alright? So, and okay, there are many more. For example, if you have a graph, okay, this is a concept now. So let's say you have a graph, alright? Let's say there is a root between 2 and 6, alright? Let's say between 2 and 6 there is a root. Roots means the x-intercept. This is the graph of fx, right? Y equals to fx. So when they intersect x, when they intersect the x-axis, the y value will be 0, right? All the y coordinate here will be 0. So it means that the fx will be 0. So what is the value of x that causing this fx to be 0? Is the roots of this equation. So to searching for the roots, I can using the searching for the sign of change, alright? Searching for a sign change. So then I'm choosing a value, okay, 6. Of course, definitely the 6 will give me a positive value, because 6 will meets the graph at the x equals to 6 will meets the graph and giving the positive y value. And definitely the one that less than the roots, the value before the roots will be getting the negative value. If you find out that f6, let's say you know that f6 is a positive value and f2 to be a negative value, any value, right, negative value, then you must very sure that there is at least a roots between this interval, right? Must have a roots. If not, how they going to passing through the right? Without the sign change, then the graph must be passing through 0 first, right? Before they go for positive. So there is a sign change. That's the concept. This is the concept. Don't memorize, alright? This is the concept. So okay, now I already explained for you. So I think if you are smart enough to understand, alright? So show that this has a root that lies between 0.6 and 1. So means I'm going to write, okay, this is my equation. Okay, I'm going to using marker. So I have e to the power of 2x, right, equals to 5 minus with x to the power of 2. How I know there is a root? I'm going to rewrite this into a function, into a single function, plus with x to the power of 2 minus with 5 equals to 0, right? So I assume this to be a function, So means the function now is e to the power of 2x plus with x to the power of 2 minus 5. So if there is a root between 0.6 and 1, right? Just I explained just now. If there is a root, the sign will change, right? If there is a root, the sign will change between these, right? The root, if the root is between these two values, the sign will change, right? From negative to positive or positive to negative, right? So okay, now I'm going to substitute the value of 0.6. Very simple. What I'm talking so far is just to deliver you the message. Alright, e to the power of 0.6 plus with 0.6 to the power of 2 minus 5. You try to calculate, you try to help me calculate e21 plus with 1 to the power of 2 minus 5. And what is the value, right? Interested about what's the value. Okay, for fast, I'm going to using calculator. Right? You're using this calculator. So, okay, let's see how to use this calculator. Very simple. So you just key in this function, right? E, shift E, 2x, right? 2x, so 2 alphabet x, right? 2 alphabet x. Okay, pressing this button, and you have plus x squared minus 5, right? Plus with alphabet x squared minus with 5. Then you have this, right? Then you're pressing the button CLC, calculate, right? Calculate. So calculate 0.6. I don't want to put one by one to the calculator, right? I'm not that hardworking. 0.6. Okay, substitute with 0.6, right? Then I'm pressing equal, double equal, right? For this calculator. Negative value. Okay, negative value. So I know this is a negative value. Negative 1.32. Okay, any value that I don't care. Okay, I just want to know there's a negative value here. So another one, I get pressing calculate, calculate. So is another one is 1, right? 1. So I just key in 1. So I'm pressing double equal 1 time, 2 time. I'm getting positive value 3.39, right? So 1 positive, 1 negative, 1 positive, right? 1 positive, 1 negative. So then the question asking you to do what? Asks you to show that the equation has a root that lies between 0.6 and 1. I have already shown because the sign is changed, right? You can explain the sign of f0.6 and 1 are different or different in sign. So are different. Therefore, there is a root between the interval 0.6, right? Between 0.6 and 1, there is a root. right? That is a root. So, okay, how exactly I want to show you is that you can actually just doing this, okay, just doing this. This definitely is true. This definitely is true. But if you want to confirm that is true, you can just key in this equation. All right. So we don't force people to accept something, right? We have to prove exponential. Okay. Put a bracket. So 2x, right? 2x. This is e to the power of 2x. E to the power of 2x plus with x squared, right? Plus with x squared. And minus with 5, right? Minus with 5. Minus with 5. Alright, done. Okay, done. So we see where's the graph, right? So just now you see, if you zoom from far, this is the graph. Okay, it's something like quadratic, right? It's something like quadratic. Don't get cheated. This is not quadratic. Okay, this is the graph for exponent 2x plus x squared minus 5, right? This graph. So if you keep zooming, actually there is two roots, you know. There is two roots. There is a two roots. So it means, okay, now I interested about the roots between 0.6 and 1, right? 0.6 and 1. So, okay, look at this. 0.6 and 1. Is it between 0.6 and 1? Yes. Yes, it's between 0.6 and 1. If you see, zoom again. It's between 0.6 and 1. Can you see that? This is the roots. I use my pen, I show here. This is the roots. This root is between 0.6 and 1. To be more exact, it's 0.6 and 0.8. But never mind. I just want to know there is a root between 0.6 and 1. So, you see that? So, that's why they have a change of sign. Right? Okay, I'm going to extend this to this. If you love maths, you try to listen what I'm saying. So, if you see that, if you see this, there is still another roots here, right? There is still another roots. So how to know that there is a root between these two? How to know there is a root between -2 and -2.5? You also can using sign of change. I teach you using this. I have key in the function, so I calculate. So let's say you choose the value -2.5. All right, let's calculate -2.5. You're getting positive, right? You're getting positive, of course lah. You see from here. You see from here. Okay lah. So you see, -2.5 is above the x-axis. Definitely the y value will be positive, right? And -2 is below the x-axis, so there will be negative. So you calculate -2. So you're getting negative. Can you see that? The sign change, right? So means that here you get positive, here you get negative, right? So of course, after from negative to positive, they must be passing through the x-axis. This is called the roots. This is another way of show that there is a root between these two values. Alright, I hope you understand the concept, okay, of searching change of a roots. Alright, so now we go for this question. Now I think you can, I think you already very good in understand what is happening, right? So okay, now go for this. So I just want to tell you more details, right, in everything that I want to explain. Show that there is a root lies between 0 and 1. So means that for x x e to the power of 3x equals to 12, right? There is a root between 0 and 1. Very easy. So 0, 3x, right? Minus with 12 equals to 0. So this is my fx. This will be my fx. So x e to the power of 3x minus with 12. So if there is a root between these two, so I will find for f0 and f1. Right? Show. They also show, definitely they already tell you that there is a root between these two. So very easy. Key in again. Right? Key in alphabet x. So shift E, 3 alphabet X, right? 3 alphabet X, then minus with 12, just like this. Calculate the value 0, -12, right? Calculate 1, positive 8.09. You have to show your substitution step. Okay, you have to show 0 e to the power 0 minus 12, right? You have to show something like this, 1 e power 3 minus 12. So you're getting 1 negative, 1 positive, right? 1 negative, 1 positive. So change of sign, ada perubahan tanda. This show that there is a root between the equation has a root between 0 and 1. That's all for this video. Alright, I have tell you the hint. The hint is searching for the sign change to prove that there is a root between here. I don't know what is the root. It can be 0.7, can be 0.8. As long as I know there is a root between these two. Alright, so that's all for this video.